Hello, everyone, and welcome back to the podcast. Have you ever wondered, why does ice float? Most solids sink into liquid, but water is different. Let's break down why. The key idea here is density. Density is how much mass is packed into a certain volume. If something is more dense than water, it sinks. If it is less dense, it floats. So for ice to float, it has to be less dense than liquid water. Water molecules are made of H2O, and they're constantly moving. In liquid water, the molecules are close together but disorganized. They can slide past each other. But when water freezes, the molecules slow down and form a very specific structure, a crystal lattice. This structure actually spaces the molecules farther apart than in liquid water. That means ice takes up more space with the same mass, so its density is lower. This is actually super important for life on Earth. Because ice floats, it forms a layer on top of lakes and oceans in cold weather. That layer insulates the water below, allowing fish and other organisms to survive instead of everything freezing solid. You can actually observe this density change yourself with a simple experiment. Fill a cup with water and add a few ice cubes. Notice how part of the ice sticks out above the surface? That's because it's less dense than the liquid water. Now here's something interesting. As the ice melts, the water level in the cup does not rise. That's because the ice was already displacing exactly the amount of water equal to its mass. This is a principle called displacement, and is closely related to density. Another cool detail is that water reaches its highest density at about 4 degrees Celsius, not at freezing. As it cools below that temperature, it actually starts expanding, even before it turns into ice. That unusual behavior is why water is considered a unique substance in chemistry. It doesn't follow the typical pattern that most materials do. So the reason ice floats comes down to density and molecular structure. Water expands when it freezes, making it less dense than its liquid form, something that's pretty rare in chemistry. That's all for today. Tune back into the podcast next video.